Okay, Unit 6 Forces, page 7. We already have videos for pages 3, 4, 5, and 6. This should complete the free body diagram videos. Each one is on the order of, I don't know, maybe 5 or 6 to 10 minutes. So if you feel like, oh, I don't know quite what you're talking about on that problem, maybe go back watch one of the beginning videos where we break down basics like how to get FG from mass and things like that. All right, so on a ramp, you are no longer dealing with X and Y the way you traditionally deal with X and Y. You are now dealing with parallel and perpendicular to the ramp. In fact, one of the ways I'll show you this, let's take a little picture of this guy. Let's put it right here. Good. And we'll come and look at this in a minute. Shrink him down a bit. We'll worry about this in a minute when we're talking about this whole parallel perpendicular. All right, we went over these notes already, so we'll just fill them in. Perpendicular, the normal force matched FG cos theta, and the parallel to the ramp component of the weight FG sine theta. We'll mention that again in a minute. There's a nice breakdown of all these over here, but basically looking at this picture, before we even understand this picture, let's just look at this picture. In this picture, the FG is dashed because what we're going to end up doing is breaking this FG into components. We're going to say we don't need that FG anymore. We actually broke it into a perpendicular component, this one, and we'll draw it over here, parallel component, this one. And so we're going to hash it out just like we did the diagonals before. And from this picture, you should now be able to figure a few things out. First, since they tell us the block is at rest, we know the net force is 0. Second, how do you make sense of the net force being 0? Well, that means everything is balanced. That means that the forces oppose each other, undo each other. Now, in this direction, normally we would think of this like vertical, but we've tilted the whole world. In fact, that's part of why I had this here. On the previous questions, this might look more like this. Forget about that little FG. It would look like this. Now we are tilting the entire world. There it goes. And when we tilt the whole world, we still need to balance our forces. And so this component of weight, this is called the perpendicular component of the weight. You say, what is he talking about? We'll see in a second. But that means perpendicular means perpendicular to the ramp. So the ramp is this way, this is this way. This is called the parallel component of the ramp, this blue arrow. Yeah? The arrow is this way, the ramp is this way, they're parallel to each other. We also have a normal force, and in this case we have a friction force. Now, nobody told you that, I drew it for you, so let's not get too fancy with it now, let's just take what the picture has. From this picture, since net force is 0, these two opposing forces have to balance, and these two opposing forces have to balance. That actually gives you two equations. The normal force is Fg perpendicular, which is Fg cos theta. Oh, look at that! We already did this. You just didn't realize that was Fg perpendicular. There it is. And we have another equation here. Hopefully you can figure it out. The friction is going to balance Fg sine theta. Because we have a net force 0. Now, for those of you who are into the geometry of it, this theta right here is, that didn't work out so well. Let's put a little highlighter on. This theta right here is the same as this theta right here. That's the angle of the incline. Now, the simplest possible way I can make this for you is, let's see, if we follow these two vectors, see if we group, oh, they're already grouped. If we rotate that pair of vectors 90 degrees and bring them over here, you see that that's the same angle. So I didn't change them relative to each other. They are, this angle and this angle are the same. You can also figure out the geometry of it a bit more if you're interested. Do it like you do in math class, you can figure it out. Anyway, where is this cosine and sine coming from? They're actually coming from your SOHCAHTOA. FG is the hypotenuse of this right triangle. The perpendicular component is adjacent to the angle, and so adjacent and hypotenuse, you get your cosine. This parallel component is opposite the angle, opposite and hypotenuse, you get your sine. So that's where those actually come from. Many students end up just memorizing it and keep it moving, because there's not too many things you have to memorize in this course. Most of it's on the reference table. That may be worth your while to memorize. Okay, let's go over here and let's do a couple of these right quick. First one over here, sliding down a rough incline at a constant speed. Well, we know the weight of the box is 10 newtons. And we know they told it to us. What other forces are going on here? We're sliding down a rough incline, so we know there's friction. How much? We're going to find out in a little bit. There's also a normal force. There is no talk of a pull, so there's no external force. There are no springs, so that's everything. In fact, the normal force we know because the normal force balances something, and it's not the Fg. Now, you could remember this because I already taught you the equation. You already know the equation. Fn equals Fg cos theta. There are situations, by the way, where this might not work, and those are advanced situations compared to the Regents content. Maybe I'll make a little advanced video if you want to check that out. Anyway, Fn is Fg cos theta, so you could very easily do 10 times cosine of 30 degrees, and that comes out to about 8.7 newtons. Great. However, the other way to think about this is the following. If we go back to this diagram, one of these forces is not lining up with the others. When we say lining up, we want them directly across from each other. Otherwise, we have to invoke law of cosines or some other business that you probably don't want to do, and is not in the reference table. So, imagine, rotate this again. That still looks tilted. There we go. Imagine how it was. They're all lined up. And now we're tilting the picture. We still want them lined up, except it's not the x and the y direction anymore. It's the perpendicular to the ramp and the parallel to the ramp. And with that perspective, it's actually Fg that's breaking the norm. Fg that's not really following the across from each other protocol. That's why this plus symbol is here. We want this all set up like a nice plus symbol. Even a rotated plus symbol is just fine. So what we say is, oh, wait a minute, the Fg is actually the resultant weight. It's the total weight. That's the hypotenuse of a right triangle. Which one? This one. And this right